welcome to section 12.5. We're going to have two new special bases. We're going to look at the natural base, which is represented with an E, and its inverse function is ln x, which would be the same as saying log base E of x, but because it's a natural base, we use a special log named ln. It's not the natural log with the initials backwards. It was a French mathematician whose initials were ln, and he gets credited for discovering the inverse of the natural base. So if we want to find out base value, just like the pi symbol is 3.14, the I is the square root of -1, E is approximately 2.718281828. It doesn't keep repeating, it does start to change. All right. If we looked at your calculator and where to find that, it's located in two places. Above the division symbol on your calculator, you will see E in the upper left-hand corner. So if I hit second division, I can get this value. Same representation. E raised to a power is above the ln button, and I'm going to show you a screenshot of those buttons in just a second. Next, we're going to talk about base 10. Base 10, 10 to the power. We saw this with scientific notation, but it has an inverse function we call the common log. Notice that there is no number as the subscript of g. If you want, you can put a 10 there. So we call it the common log because our entire number system is based off of base 10, so therefore no subscript. Now if I wanted to graph e to the x, y raised to the power of x, I can put this in my calculator, look at the table instead of second graph. We'll activate the table and look at your values. Here's -1 and 3.36788. Plot it. There's 0, 1, which we have to have. That's our common point. 1, 2.7183. Again, that's our value of base E. Plot it. And then here's E squared, 7.389. Plot it. It's the same form of a basic exponential curve. Nothing really changes there, so all is good. Now these are going to be probably tougher to graph because you don't hit the corners of the squares really nice. In fact, your common point is the only point that hits the grid lines. So the rest of them are going to be approximations. This is why you want to be accessing your table as often as possible. Now, if you were asked to find the following values on your calculator, you're going to look in the left-hand column. This is just to the left of number 7 and to the left of number 4. This is your common log, base 10. You'll notice that I have to hit second log to activate 10 raised to a power. And if I want E raised to a power, I will hit second the ln button to activate E to the x. So my calculator entry for E to the 4th would be second, the ln button, I'll get the E, I'll get a little square text box up here, put in the 4, hit enter, and this is the value you should get, 54.59815. 10 to the 3rd power, I'll just hit second log. It gives me the 10, puts the text box up here. And then we'll put in 3.7, get 5,011.87, yada, yada, yada. Natural log is 73. Hit the ln button. It'll put the parentheses, fill it in with 73. There's your decimal representation. Common log, base 10 of 851. Just hit the log button. Put in your 851, 2.929929, so on and so forth. So if we want to graph, all right, if I wanted to graph base E, again, here's my table. My 3 graphing points, -1, 0, and 1 for x. The 0.3679, that's your 1 over E. Here's your common point. This is 1 comma e as a decimal representation. So again, just those 3 points and your horizontal asymptote. So if I have e to the x minus 2 minus 3, our orders start, for our transformations, start in the exponent position. Set that equal to 0, solve it for x equals 2, so we're shifting 2 to the right. All 3 dots go 2 squares to the right. The minus 3 on the outside, we said in class, this is going to be changing things up and down. So every point goes down 3, including your horizontal asymptote. Move your points, draw your curve, and you're good to go. Now again, don't get me wrong, you can put this in your calculator. I could have y1 be e raised to the x minus 2, jump out of the exponent position, put in minus 3, and since that minus 3 is going to be the location of my horizontal asymptote, and y2, I graph the constant negative 3, so I can graph it. There's my horizontal asymptote. 2, negative 2, that's the check of your common point. 2 to the right, down 3, puts me at 2, negative 2. That matches up, so I know everything's looking good. If we wanted to plot negative e to the x plus 2, again, same 3 starting points. Start with the multiplication of the negative. It's outside the exponential function, so this is up and down. So this is going to flip over the x-axis. So 2.7 above, now below. 1 above, 1 below. 0.3 above, 0.3 below. Plus 2, the purple points all shift up 2 squares, which means even my horizontal asymptote also jumps up 2 squares. Reshift those points, plot your curve, and we'll call it done. Then have your calculator check it. y1 is negative e to the x plus 2. The constant plus 2, put that in y2 to get my horizontal asymptote. Watch my common point, started at 0, 1. Flipped down to 0, negative 1, then shifted up 2 and happens to be at the exact same point. Type in 0, 1, get 1 for the y. Everything matches up, so I consider that good. Okay, next example. Negative e to the negative x is what we want to graph. So again, start with those 3 graphing points. Have my horizontal asymptote. The negative on the x is first. Orders of operation. Exponents come before multiplication. In the exponent position, there's a negative 1, so that's going to flip us over the x-axis. Excuse me, check y-axis. I apologize for that. Then we flip it over the x-axis, and there's our final graph. Again, your calculator can assist you. Negative e to the negative x. My horizontal asymptote didn't change, so y sub 2 equals 0. Hit the graph button, hit the trace, type in 0. I had negative 1. For a y coordinate, that's right where I need to be. So as long as these 3 points started out right, we're in business. Now when we talk about the inverses of the natural base e to the x, there's my 3 graphing points. When I want to go to its inverse function, the natural log, then flip those around. 1 over e comma negative 1, 1, 0, e to the 1. Flip these decimal values around. Those are going to be your starting points for your natural log graph. So 0.37, negative 1, 1, 0, 2.72, and a 1. Now the x-axis, or y equals 0 for the exponential graph, that horizontal asymptote now becomes x equals 0, the y-axis. So I'll draw that in for my natural log. So on my calculator, here's e to the x will be in blue, natural log of x in red. I can graph it, and you can see there's my common point at 1, 0 on my natural log graph. And again, notice how this red curve appears to stop, because the next pixels it's going to touch is going to be on the y-axis when x equals 0, and we can't touch it. All right, it appears to be touching over here, but again, it's not. If you trace out there, y will never equal 0. All right, next example, we want to graph natural log of x minus 2. So setting this equal to 0, it's in the parentheses. We'll be going to the right 2. So again, start with my 3 starting points for my natural log right here. Then shift everybody to the right 2, including the vertical asymptote. Plot your points, draw your curve. Don't touch that vertical asymptote. And again, you can do a calculator check. The downside is you will not be able to draw in a vertical line, but you can type this into y1 just as you see it to verify everything works. Negative natural log of x minus 2. There's my 3 starting points. My vertical asymptote. Flip, it's on the outside of the natural log. I have to flip up and down, so it's going to go over the x-axis. So we'll flip that real quick. There we go. And then the minus 2 says all the purple points, you go down 2 squares. Draw my curve, and there's my equation. Represented on the graph. I guess I should say there's my graph, not there's my equation. Next, we're going to talk about the change of base formula. This is still very important. Your calculator does this, and it actually has a mini program under the math button, which I will show you, and how you can activate it. All right, so if your calculator does not have that little program under the math button, then you need to type this in yourself. So let's say I had log base 13 of 39, and I have to find my answer to 3 decimal places. We don't have a log base 13 on our calculator for a button. All we have is log base 10, the common log, and the natural log, which is base e. That's the only 2 we have. Well, using this base change formula, it says if you're given any log, you can take the common log of the original argument and divide it by the common log of the old base. It also works if you use the natural log command. So here's log base 13 of 39. I can write it as the common log of 39 over the common log of 13. I could also write it as the natural log of 39 over the natural log of 13. Both are acceptable. I go to my calculator. Here's log 39, close the parentheses, divided by log of 13. Remember, it will put in the left parentheses for you. You have to remember to close it. I like to store it in for x right away. Now, when it comes to the calculator, and when I want to use for the base change formula, I always use natural log because everything has a tendency to fit on one line. Still the same decimal. So now if you think about this, this is base 13 raised to this long decimal, which we stored in x. I hit enter, it says 39. That's this number right here. So now I know it is correct. So doing that is like my conversion check to make sure that everything works. If we had log base 21 of 5, all right, use your base change, write it out. It's going to be the common log of 5 on the top, divided by the common log of 21 on the bottom. And again, we'll go to the calculator. I told you I like to use natural logs instead. So the natural log of 5, close the parentheses, divided by natural log of 21, close the parentheses, store it in x. Then take your base 21, raise it to that x power, and sure enough, it equals 5. log base square root 11 of 8, convert it, common log of 8 on the top, common log of the square root 11 on the bottom. We'll go enter this into the calculator. Natural log of 8 divided by the natural log of the square root of 11. Store it in x. Then do a conversion check. Old base square root of 11 raised to the x power equals 8. Now, if you're using the newer calculators, I'll move mine over here real quick, and I want to do the base change formula. You can still use your alpha y equals. Let's see, let me move this over a little bit. Come on. Okay, it won't let me move it because I got to choose this first. Is that the reason? Nope, that is weird. I can make it bigger or smaller, but I can't move it. That's weird. All right, so we had, okay, I'm going to try to move you over. There we go. So log base 13 of 39, I can type in natural log of 39 on the top, close the parentheses, jump down to the bottom, natural log of 13, just make sure you use the same log buttons. Like I said, I like to store it in x. And then to do my check, base 13 raised to the x power. There's my 39. So now I know everything checks out and it works. Now it moves. Strangest things. All right, now in your calculator, we can also evaluate 3 to the x equals 581. 581 is not technically a base 3 number. So again, what we'll do is take this and convert it into a log by the conversion rule. So x, you go over to the right by itself, 581. You're going to go in with base 3 and the log function. So log base 3 of 581 is equal to x. So the natural log of the argument 581 divided by the natural log of the old base 3. Type it into your calculator, round it to 4 decimal places, you'll get 5.7934. All right, back to my calculator. Now, I had mentioned under the math button, if you scroll down to option A, there's log base. You hit enter and you get empty text boxes. So again, if I wanted to, this is nothing but a program where you type in the base in that text box, 13. You type in the argument, 39. And again, you can store it for x to double check it. But what the calculator does is it takes the 13 and the 39 based off of these locations. They're stored in variables. And they plug them into this command right here to get your decimal representation. There we go. Now, again, you have to know this formula. You will be required to know that formula. So don't always go to that log-based command. Practice your base change formula. I guarantee you I'm going to ask it on the test. All right, there's my screenshots of what we had there. Now, if I want to graph log base 5, again, think about your 3 starting points. Well, there's 1, 0, my common point. My think exponentially was negative 1 comma 1 over the base. I flip it around. Base is 5, 1/5 comma negative 1. And here's 5 comma 1. We reverse the rule steps for exponential because we're dealing with its inverse. So there's my 3 starting points. If I want to do y equals log base 5 of x plus 2 tells me to shift all these points up to, and there's my graph. What I want to point out here is that these can now be done in the calculator. Here is the base change formula, natural log of x divided by the natural log of the base 5, then add 2, change your window so it matches x min, negative 6, x max, positive 6, y min, negative 6, y max, positive 6. Leave everything else alone. I graph it, and there's my graph. This point is at 1/5, comma 1, that's 0.2. There's 1, 2. There's 5, 3. Again, you can go to your calculator, use that log base command under the math button, put the 5 in the text box for the base, x in the argument plus 2. So now it kind of looks exactly what you see here. And then this will put it into the base change formula and crunch everything. And there's my graph, very similar to what we have here. Again, you can hit the trace button and verify those points. Log base 4 of x minus 1, so my log base 4 here in red, 1/4, comma negative 1, that's the 1 over b, comma negative 1, 1, 0, 4, 1. X minus 1 on the inside, we set this equal to 0, solve it for x equals a positive 1. So therefore we're going to the right 1 squared, but don't forget you also move the vertical asymptote, connect the dots. On my calculator, base change formula, if you don't have the log base command underneath the math button, there's my graph. Again, 1.25, negative 1. That's this point that was at 0.25 or 1/4, bumped to the right 1, 1.25. Common point was at 1, 0. It's now at 2, 0. This point was at 4, 1. Now it's at 5, 1. Everything matches up. And for your log base command underneath the math button, which is really nice because you make this look exactly the same in your calculator, and then I can graph it and I get the same picture. Log base 2 of x, all right, 1 over b, comma negative 1, 1, 0, the base, comma 1, then the base squared, comma 2, so now we have 4 starting points. So if I want to have log base 2 of x plus 4 minus 2, inside the parentheses, solve this for x equals negative 4. We're going to the left 4. Then that means your vertical asymptote must move as well. Minus 2 says the purple points all go down 2. Draw in the curve, and we're good to go. Check it on your calculator. Base change formula, ln of x plus 4 divided by ln of 2 with the minus 2 on the outside. We graph it. You check your points. 1, 2, 3.5, negative 3.5. I'm at negative 3 for the y. Negative 3, negative 2, negative 2, negative 1, 0, 0. All my points match up. The newer calculator, you can use, again, the log base command underneath the math button down at choice A. You get the text boxes, you fill everything in. You can go ahead and graph it, and you pretty much get the same picture. Again, vertical asymptotes will not be drawn in. You can't graph a vertical line in y equals because that represents functions, and this doesn't pass the vertical line test. All right, so I hope that helps with your graphing.